Hello students, let us learn the Laplace transform of functions where we apply the shifting property. So consider the example, find the Laplace transform of e raised to 3t into sine square t. So here function is multiplied, whatever the function we have e raised to 3t into sine square t, we can see that it is product of two functions and uh, it is e raised to at into f of t form will consider it as, so that we can apply this shifting property. We know that Laplace transform of, if Laplace transform of f of t is given by f of s, then whenever this f of t is multiplied by e raised to at term, then we just need to replace our s by s minus a. That is our shifting property. So considering this example in that form, now we will skip this e raised to at term, and whatever the remaining function is there, let us call it as f of t. So if you skip the e raised to 3t term, whatever the function remains, it is sine square t. So let us call that sine square t as f of t. Now the Laplace transform of f of t, it is equal to, that is, we will apply Laplace transform on both sides. It is Laplace transform of sine square t. But sine square t cannot be evaluated directly, so we'll apply the formula. It is 1 minus cos 2t divided by 2. Let us keep 1 by 2 outside. Laplace transform of 1 is 1 by s. Then minus we have Laplace transform of cos 2t. Laplace transform of cos at is s upon s square plus a square. So we have here s upon s square plus 2 square, because a is 2. A is 2 here. This 1 by 2, it is kept outside. Now let us simplify this. 1 by 2 we have, if you take LCM, it is s square plus 4 into 1. We get s square plus 4, minus we have s into s, that is s square. So s square gets cancelled. What remains is 4 divided by s into s square plus 4. Now if we cancel this 2 and 4, we get 2 divided by s into s square plus 4. Since we have taken the given function as f of t, so the Laplace transform of the function f of t, will write it as f of s. Now applying this shifting property, we have obtained the Laplace transform of f of t as f of s. Now when the function will be multiplied by a e raised to at term, here it is e raised to 3t, then what we need to do is just replace our s by s minus a. If it is multiplied by e raised to at, s is replaced by s minus a. Now here function is replaced by e raised to 3t. So in our f of s, s is replaced by s minus 3. We'll write this f of s, 2 divided by s into s square plus 4, where s should be replaced by s minus 3. So just replace it 2 as it is. S is replaced by s minus 3. Then again this s is replaced by s minus 3. Its square we have, then plus 4. That is the Laplace transform of e raised to 3t into sine square t. Let us consider one more example. Find the Laplace transform of sin h3t minus cos cube t. So here it is not in the standard form. It is product of two functions. So let us first bring it to the standard form. So it is sin h3t, we are kept as it is. For cos cube t, to remove this cube term and write it in the simplest form, we'll use the formula for cos cube theta. It is 1 by 4, 3 times cos theta plus cos 3 theta. So theta, instead of theta we have t here. So it is 1 by 4, 3 cos t plus cos 3t. Now again we'll apply the formula for sin h3t. It is e raised to 3t minus e raised to minus 3t divided by 2, and this term it is written as it is. Now this 2 into 4 will get 1 by 8 outside. Now let us take the product. We'll open this bracket. So it is Laplace transform outside. It is e raised to 3t into 3 cos t. So it is 3 times e raised to 3t into cos t. Second term, it is e raised to 3t into cos 3t. So it is e raised to 3t into cos 3t. Next we have this term minus e raised to minus 3t into 3 cos t. 3 is written first, minus outside here, e raised to minus 3t into cos t. Now last product, minus e raised to minus 3t into we have cos 3t. So now we need to find the Laplace transform of all these functions. We have turned this product into all sum terms. So we'll find the Laplace transform. Now 3 is constant, it is kept as it is. Laplace transform of e raised to 3t into cos t we have, which is in the form of e raised to at into cos t. So what we'll do is we'll find the Laplace transform of this cos t and then replace our s by s minus 3 because our a is here 3. So Laplace transform of cos t, it is s divided by s square plus 1, but this becomes only the Laplace transform of cos t. Since the function is multiplied by e raised to 3t, we need to replace s by s minus 3. Okay, then plus now we'll go to this next term. It's Laplace transform. Laplace transform of cos 3t, it is s divided by s square plus 9, and here function is multiplied by e raised to 3t. Again we'll replace s by s minus 3. Then here minus 3, it is constant, we'll keep outside. Again it is in the form of e raised to at into f of t. Find the Laplace transform of cos t. It is s divided by s square plus 1. Then here it is multiplied by e raised to minus 3t. We will replace s by s minus a. But a is minus 3. So minus of minus, we'll get it as s plus 3. Okay. Then minus as it is. Again, it is e raised to minus 3t into cos 3t. So Laplace transform of cos 3t, it is s divided by s square plus 3 square. So we have written here s divided by s square plus 3 square is 9. Now if the function is multiplied by e raised to at, then s is to be replaced by s minus a. But here a is minus 3. So s will be replaced by s plus 3. Now replace all the s's by the corresponding terms written there. Now it is 3. Then s is replaced by s minus 3 divided by s minus 3 whole square plus 1, plus we have again here s is replaced by s minus 3, then divided by we have s minus 3 whole square plus 9, then minus this term 3 constant, s is replaced by s plus 3, again here s is replaced by s plus 3 whole square, then plus 1. Then the last term, s is again replaced by s plus 3. Then here s square is the s is replaced by s plus 3 its square. Then we have plus 9. This is the Laplace transform of sin h3t into cos cube t. Thank you.